Hello, everyone. Okay, welcome back. So this talk will be a little bit technical, so I hope people don't fall asleep. But let's get started. But the first half would be less technical, so hopefully everyone can get on the same page. So advances in semi-supervised learning. But let me get started by just telling you the basic first. So let's talk about just basic supervised learning. So in case people don't know, in machine learning, I mean, if you tell your friends you know supervised learning, maybe they will be surprised. So let me just give you some idea what does supervised learning mean. So if you have an image, this is your input, and then you have a label which is a cat, and supervised learning always require input and label. So you teach the AI to learn how to recognize an image, whether this is a cat or a dog. So this is a picture of how neural networks work. So neural network is a new technology or deep learning that inspired by the human brain. So what you see here is a picture of many layers, and these are like neurons, the little dot, they connected. And the goal of neural network is just, by just looking at lots of images like this, you have image of cat, image of dog, any animals, and it will figure out, by going up here, if it classifies it's the dog, it's wrong, it will, adjust the weight, and then gradually as it see more and more images, it can learn to classify correctly. So in the real world situations, a lot of the time you only have little data. You have just maybe a small amount of, label data. For example, in healthcare, you don't always have lots of label data, where you need people to look at the data, to annotate it. It's very costly. But on the contrary, you have a lot of unlabeled data. You can have lots of different cats, but no one tell you these are the cats. You can see a lot of these pictures on the internet. So recently, Andrew Ng at Amazon event also talked about the importance of going from big data into small data. I think a lot of people talk about big data, right? But I think techniques for that work on small data is also very important. Let me give you an example. So Andrew Ng worked on manufacturing, helping worker to decide whether your phone is okay or if there's a scratch on your phone. But a lot of the time you don't have the label of scratch phone, right? Because manufacturers don't make scratch phone. So you don't have that many examples of broken phone. So because of that, the example is very little. And which actually lead us to how to do things very well when you have small label data, which is the supervised part, and when you have large unlabeled data, which is the semi-supervised part. So this topic has been around for a very long time. If you look at the picture on the left, this actually describes to you the relationship between supervised learning and semi-supervised learning. And then the axis here is how much label data you have. So when you have little data, semi-supervised learning works very well, work better than supervised learning. But it's not that good. It's just the performance is still very low. And then by the time you get more and more data, it just simply better to use supervised learning because it's simpler. But then recently, there's a magic where the curve of semi-supervised learning actually go above when you have a bit more data. And someone called this one a quiet semi-supervised learning revolution. And they mentioned our work here. So it's actually just this year. This is our work, and also this is our college work. So the idea is about utilizing lots of unlabeled data, but you just add in some noise, so the system more robust to the noise added to the examples. So this is the work by me, Quark, and other colleges at Google Brain. And the work is called Unsupervised Data Augmentation for Consistency Training. And, oops, oh yeah, I forgot. This is I think this is just copy and paste. This is Ji Sia, this is Zhu Handai, Ed Hovey, they're from CMU, and me, and Kwok. Sorry about this, not for Thang Luong. I guess by now maybe people start to fall asleep. I'm going to go very quickly through the remaining part, which is a little bit more technical. So let me give you what is consistency training in semi-supervised learning. So on the left part here, you have label data, like image of a cat and the label cat. And you build a model. This is they have the kind of supervised cross-entropy loss. And when you have a lot of unlabeled data, what you're going to do is you add a little bit of noise to your input data. So you get a little different image. They're still the same, but sometimes you rotate the image, you increase the background color to make it brighter. And then you run the same model through each of the input so that you get the prediction for each of the image. And then the consistency loss is to say that, okay, the prediction for these two images should be the same. So by doing the consistency training, people want to make sure that when you add a little bit of noise to your input data, the system is still robust. And by doing that, the model can learn to propagate the label from label data into unlabeled examples. And I won't go into details of this picture, but just to give you a sense, like the color dots here are labeled example, and then the uncolored ones are unlabeled example. So at first, the model sort of, infer that those around the labeled example are the same class, but they still make mistakes, and they still tangle together. And as you keep going, they fix the error here, and then it gets better and better over time. And you can do that because you have the kind of consistency loss here, where you sort of, okay, you take an image, you change them a little bit, and then the model learn to connect different images together. So for UDA, what we did differently actually are very simple changes. Instead of adding the noise, we add a better noise, better kinds of noise. We add augmentation method to change our input. So what do I mean by augmentation? So let me give you an example. Okay, so for example, for language, if you have a sentence like an input, what you do is you translate to French, and then you translate back into English, and then now you have a new sentence. For example, if you have the sentence like given the low budget and product limitation, this movie is very good. When you change it, you have a new sentence like there are few budget items and production limitation to make this film a really good one. So you know that the language is a bit different, but it still have similar meaning. And this is how we actually manipulate our input so that the model gets to be more robust to the input changes. And for vision, what we do is we run a technique called random augment, where it just tries different ways of changing your input. It can crop an image, it can rotate, it can zoom in, it can add different color. So from an unlabeled example, you get other unlabeled example, and then the model will learn to make similar prediction between the example. And by doing that, we was able to get state-of-the-art performance for language application with just 20 examples. And this is better than technique that use 20,000 examples, much more data than what we have. And what you can see here, the curve here is semi-supervised learning, the blue curve, and the gray curve is the supervised learning. And we're actually always ahead of the supervised learning curve. And this agrees with what you see before in the article about the quiet revolution of semi-supervised learning. And for vision as well, I won't go into details, but you will see that our model UDA was able to outperform existing techniques by a huge amount of, by 30%. And we can get very good performance by only use 4,000 examples compared to a system that use like 50,000 example. So this is like 10 times less data. So in summary, I think it's important to think about the transition from big data into small data. I think as Andrew put it. And this is important in manufacturing, in healthcare, and I'm sure there's a lot of other areas that you might think about. And semi-supervised learning is getting better and better. And I think UDA is one approach, and I'm sure there will be more and more improvements. Okay, thank you.